Hey everybody, this is Coach Brian coming to you with the 5.6 notes. 5.6 is all about altitudes and medians of triangles. We're going to start these notes by introducing some new terms to you, showing what they mean, how to find them, and what it actually tells us on a triangle. And so let's jump right into it with altitudes. All right, altitudes are the height of the triangle, And you, to locate it, all right, if I have a triangle that's A, B, and C, I would start at B and connect to AC at a right angle, 90-degree angle. So what I would essentially do is find point B up here, find this angle, and I would draw down until I connect with AC at a 90-degree angle. Now you can actually find it mathematically too in 3 steps. First step would be find the slope of AC. Now in this particular example, it's a horizontal line. So its slope would be y equals something. And so the perpendicular line would be, the perpendicular vertical line would be something that's x equals. But that's not always the case. So it might be helpful. I don't know if I can pick the same color I had. It might be helpful to, messed that up. To have your formulas ready. And so if you need to find the slope, it is y2 minus y1 over x2 minus x1. So if you know the points, the coordinates of A and C, you could plug those in, find their slope, and then you go to step 2, which would be find the perpendicular slope. And the reason you want to find the perpendicular slope is because you are trying to create that 90-degree angle up here. All right, you want those lines to intersect at a 90-degree angle. And if you remember, you find the perpendicular slope by finding the negative reciprocal, which means you're going to flip the fraction and flip the sign. And then our final step is, once you have those two things, start at point B, and use your new slope to connect to AC. An important thing to remember is that this may not, and probably will not, be a bisector, meaning it doesn't have to split angle B into 2 equal parts. All right, our second thing is our median. All right, our median takes this same triangle, and again, not necessarily a bisector, doesn't have to be a bisector, but it does create 2 equal triangles. And what it actually is the midpoint of AC connected to angle B. So how to find it? Step 1, find the midpoint of AC. So if I go back to our picture up here and I say, I think that's the midpoint right there. That's the midpoint of AC. I would then, from that line, go to the center of angle B, and I would connect them. Sorry, that line did not start off so great, but I would connect them and create 2 equal triangles. So after you find the midpoint of AC, you would use your midpoint and point B to find slope, and then step 3, connect. So if you were using a coordinate plane and you actually had an XY for B and you had an XY for the midpoint, you could then use those two and use the slope formula. So just before you go on too much further, you may want to look back into your older notes and use your slope formula, your midpoint formula, and possibly even your distance formula. Those would probably be 3 to have handy. That would be helpful for you. Okay. All right, moving on. We have another new concept called the orthocenter. And the orthocenter is the location where 3 altitudes meet. And so what is the altitude? Well, you would just look right up above here. And it is from an angle to the opposite side at a right angle. So if I'm just going to sketch rough lines on here. I'm not doing any kind of like official math, but if I just drew from C to this line and I was like, oh, that's a right angle, and I drew from A over to this opposite side and I said, oh, that's a right angle. Again, I'm not sure how accurate these are, but I drew from angle B over here and I was like, oh, that's a right angle. This point where they all 3 intersect is my orthocenter. My centroid is, let me pick a new color here. My centroid is where 3 altitudes meet. So the orthocenter is where the 3 altitudes meet. The centroid is where the 3. Oh, I'm sorry, I made it. I'm glad I proofread over that. Sorry. The centroid is where 3 medians meet. So 3 altitudes, 3 medians. And so if you don't know what the median is, you would just look up above and you're like, oh, it's where the midpoint of a line intersects the opposite angle. So if I find the middle of AB and the middle of BC and the middle of AC, and I'm connecting those to the opposite angles, then you'll see that all of these 3 intersect at a central point, and that central point is the centroid. All right, that's the centroid, and this is the orthocenter. And both of those will be useful for telling us some information. There is a theorem that goes along with the centroid, and it is that the centroid is 2/3 from the vertex of the angle and is 1/3 from the side or the line. And so this distance from the centroid to the vertex is 2/3 of the total, and from the vertex to the side, which is AC, that's 1/3 of the total distance. So that will be useful coming up. And then lastly, when we are writing the equations of lines, we use very often point slope form. Y minus y1 equals m times x minus x1. Remember, you can use this when you have a slope and a point. And you use this to find slope-intercept form, which is y equals mx plus b. All right, so a lot of information up front. Obviously, in these notes, the four main categories or four main topics being altitudes, medians, orthocenters, and centroids. So keep this table handy as you work through the following examples, and especially as you work through your practice, so that you can refer back to it, okay? So in this case, working on our first example here, we have a triangle, ABC, and it tells us that from F to B, okay, from F right here all the way to B is 21 units, and O, pick a different color here, from O to E is 4 units. And it wants me to find the length of OB, so O to B, just kind of squiggle along that line right there, and A to E. A to E is this entire line across here. And so the first thing you have to do is identify what all these lines are and what the significance of them is. And so the very first thing I want to point out is all of the marks on the sides of the triangles. All right, see how these both have 3 marks? That means they're congruent. That means that point D is a midpoint. Moving to the other side, these have the same marks. Sorry, that was not a great connection there. These have the same marks, so they are congruent. And since you have the same amount on both sides of the point, that means F is also a midpoint. And on my last side also, as I look at the fact that they have matching marks, that lets me know they are congruent and that E is a midpoint. All of these are midpoints. And if you look, if I draw a line straight across them, they all connect to the opposite angles. And when you have midpoints connected to opposite angles, opposite angles. I cannot write. You have midpoints connected to opposite angles. That means they are centroids. So if we refer back up to our notes here, centroids are where all the three medians meet. And if I look further up, a median is when you connect a midpoint to the opposite angle. And then we have this theorem that if I'm measuring from the vertex to the centroid, all right, let's just say I have a triangle right here. If I'm measuring from the vertex of this angle to the centroid, that's 2/3 of the way. And from the centroid to the side is 1/3 of the way. So with these pieces of given information, I can find out what these remaining side, or not really side lengths, but the median lengths are. And so if I'm looking at O to E right here, and it's 4, I know that it is also 1/3 of this entire distance. Okay? So I know that, if I kind of use my words here to make an equation, I can say, I know that OE equals 1/3 of AE. All right, AE, and that's what I'm trying to find out. So I know that OE, because it's given, is 4. So if 4 is 1/3 of AE, and I want to cancel out this 1/3, I would just multiply both sides by 3. And 12 equals AE. So that means this whole distance from A to E is 12 units. So that's the first thing they asked me to find. The other thing they asked me to find is O to B. So from O to B, and this one's a little bit different. I know the entire length of this one, okay, FB is 21. And if I'm going from O to B, that's from the vertex to the centroid, and that is 2/3 of the total length. So again, kind of like say what you're looking for and use that to create a formula. I know that OB equals 2/3 of FB. And then plug in what you know. OB equals 2/3 of 21. And then you could just multiply that, all right? 21 times 2/3 is the same as saying 42 over 3, because 21 times 2 is 42, and that's over 3. And 42 divided by 3 is 14. So OB equals 14. And those are the two things that asked me to find, AE and OB. All right, moving forward now, example 2. It says write the equation of altitude, JK, of the triangle GHJ. And if we go up to our definitions at the top, the altitude is when you start at a given vertex and you connect it to the opposite side at a right angle. All right, and we have our 3 steps here of how to find it. We're going to find the slope, then find the perpendicular slope, and then we're going to start at point B and use that slope to connect. So if I look down here, it's looking for the altitude of JK. K is just going to be the point on this line where that 90-degree angle occurs. And so what I've got to do first is I've got to find the slope, of line GH, the slope this line that I just outlined in red right here. I want to find its slope. And yes, you could just count over and up, but I'm going to actually find it algebraically. So G is at 0.22, H is at -4, -1, and my slope formula is y2 minus y1 over x2 minus x1. So if I go over here and I say this is x1, y1, this is x2, y2, now I can just plug those into my formula. So I've got -1 minus 2 divided by -4 minus 2. And -1, take away 2 more is -3. And -4, take away 2 more is -6. Well, a negative divided by a negative is a positive. And if I reduce this fraction, it is 1/2. So that's the slope of GH, all right? The slope of GH is 1/2. Second step is to find the perpendicular slope. So to find that, I have to find the negative reciprocal. Perpendicular slope equals negative reciprocal, which means I'm going to take that original fraction, +1/2. I am going to flip the fraction 2/1, and I'm going to change the sign, -2/1. And then for the final step, I'm going to start at point J, all right? Start at point J. I'm going to use this perpendicular slope that I just found, and I'm going to go down 2/1, down 2/1, down 2/1, and at that point, I have crossed through GH, and I can also connect those lines and know that they are perpendicular. This is perpendicular to that line. And so the equation of this new line, because that's ultimately what it asks us to find, it says write the equation. All right, I could do this a couple of ways. I could use point slope form, or I could look at this y-intercept, see where it crosses at 0, 2, and I know the slope, -2, and so I could just write y equals -2x plus 2. That is the equation of JK. And again, if it helps, you can just go right here and put a K. That way you know it's J to K. Now, just to show you, if you weren't sure what the y-intercept was or it's not clear, you could use point slope form. And so that's what we talked about on the first page, where we have y minus y1 equals m times x minus x1. And you would just pick out any point on JK. So let's use this one right here, -1, 4. So our point is -1, 4. And our slope is still here, -2. So that would be x1, and that would be y1, and we would just plug them in. So y minus 4 equals -2, x minus -1. And first step would be to distribute. So we have -2x, and this becomes a positive, so -2. And then we would just add 4 to both sides. So we'd cancel out that 4, we'd add 4 over here, and we'd get, again, y equals negative 2x plus 2. So we got the same answer either way, but this way is just a little nicer because you can actually confirm your y-intercept. All right. Example number 3 says to write the equation of the median QR of triangle RST. The equation of the median. And so if we go back up, just want to keep referring to this. What is a median? It's when you have a midpoint of a side, and you connect it to the opposite angle. Midpoint of a side, and you connect it to the opposite angle. And the point where all those intersect is called your centroid. So we are, in this particular problem, looking at triangle RST, and we're trying to write QR. And so the first thing that we want to do is to find the midpoint of ST. Sorry, I'm outlining this in a color that's very dark, so let me actually pick something that's a little brighter. All right, we're looking for the midpoint of ST. And what we can do with our midpoint, is we can find S coordinates. It's at 7, 4. And we can find T coordinates. It's at 3, negative 2. And we can plug those into the midpoint formula, which, if you remember, we take our x's and we add them together and we divide them by 2 because that's going to get us in the middle. Then we take our y's and we add them together and we divide by 2 because that'll put us in the middle. So then we can just say this is x1, y1, this is x2, y2, x2, y2, and we can plug those in to this formula. So I would have 3 plus 7 over 2, and then I would have negative 2 plus 4 over 2. And if you do that quick math, 3 plus 7 is 10 over 2 equals 5. And then negative 2 plus 4 is 2 over 2, which is 1. And so my midpoint is the point 5, 1. That's my midpoint. So I'd go over 5 and I'd go up 1, and that is my midpoint. So that's my first step. So the next thing, since I'm looking for the median, I've got this midpoint, and in our instructions it says call it QR. So I've already got R over here. This is going to be point Q. Okay, that's going to be point Q. And point Q to R is what we are trying to find an equation for. And so those 2 points, all right, Q and R, have coordinates. Q is at 5, 1. I know that because it's what I found up here. And R is at 0, 2. Again, just off of my graph. So I can actually use those 2 lines and find their slope. And the nice thing is that this point R is already a y-intercept. So I know that when I put it in y equals mx plus b, it should be plus 2 because that's my y-intercept. So let's find their slope. The slope is going to be y2 minus y1 divided by x2 minus x1. And so again, you can pick, I'll do x1, y1, x2, y2. And so y2 is 2, minus 1 over 0 minus 5. And so 2 minus 1 is 1. 0 minus 5 is negative 5. And so my slope is negative 1/5. That means it's going to go down 1 and to the right 5. Or it could go up 1 to the left 5. But if we look at this in particular, we go down 1 over, let me pick a different color. We go down 1 and then over 1, 2, 3, 4, 5. So we can confirm that that's right. So we have a line that has a slope of negative 1/5 and has a y-intercept of plus 2. And that gives us the equation of QR. For our last example, I'm actually going to use the same grid. So I'm going to erase everything off here just to clear it up and make it a little less confusing. So for this fourth example, it says find the coordinates of the centroid. All right, we're looking for the coordinates of the centroid. So we're looking for an x and a y of the centroid. And it's a new triangle, triangle ABC. A is at 0, 4. Okay, that's A. B is at 8, 0. And C is at 10, 8. Now, I know this graph only goes up to 8, but you could say 9, 10, and then it only goes up to 7, so you could say that's 8. So 10, 8 is like right up here, okay? That's point C. I know we're kind of stretching it a little bit. Now, what I want to do, just so I can visualize this triangle, is I'm just going to connect these points. So I've got C connected with A, okay? I've got C connected with B, and then I've got A connected to B. So this, like I said, this is my new triangle. I'm using the same grid for question number 4. And now what it actually asked me to find is the coordinates of the centroid. So if I go back up to the top of my notes, the centroid is where all of the medians meet. It's where all of the medians meet. So that means got quite a few steps here, okay? I've got to find the midpoint of AC. I've got to find the midpoint of AC. I've also got to find the midpoint of A to B. And I've also got to find the midpoint of C to B. All right? So I got to find all of those midpoints. Then I will connect them to their opposite vertices, and that will reveal my centroid. Okay? So let's start with our midpoint formula. Midpoint formula, which is, I'll write it over here. x2 plus x1 over 2, comma, y2 plus y1 over 2. Sorry. Close enough. All right, so I have to do that for all these points. So what I find helps me is to just write the 2 points I'm dealing with. A is 0, 4. C is 10, 8. A is 0, 4. B is 8, 0. C is 10, 8. B is 8, 0. And then the next step, I try to remind my students to do this every time. The ones who do tend to make less mistakes. Just label all of your letters That way you're not trying to keep up with everything or losing track of it if you're trying to do it all mentally. All right, so I've got x2 plus x1. So 10 plus 0 over 2, comma, 8 plus 4 over 2. So when I simplify those fractions, 10 plus nothing is 10, divided by 2 is 5. 8 plus 4 is 12, divided by 2 is 6. So the midpoint of A to C is at 5, 6. That's a midpoint. Next, x2 plus x1 over 2, y2 plus y1 over 2. If I simplify those, 8 plus nothing is still 8, divided by 2 is 4. 0 plus 4 is 4. 4 divided by 2 is 2. So the midpoint of A to B is at 4, 2. That's my midpoint. Lastly, I've got x2 plus x1 over 2, y2 plus y1 over 2. When I simplify that, 8 plus 10 is 18, divided by 2 is 9. 0 plus 8 is 8, divided by 2 is 4. And so I have a midpoint for BC at 9, positive 4, which is right here, still barely on our graph, but works out. Now, what I am going to do is connect them to their opposite vertices. So if I go from the yellow midpoint I just drew over to A, I connect those two. And if you look, the slope of that line, all right, we'll call it angle A to CB. The slope is 0. How do you know the slope is 0? Well, it's a perfectly flat line. Look, they go from 4 to 4. So you have no rise, and that means your slope is nothing, okay? When I'm counting the slope here from this midpoint to C, I go up from 2 to 8. So my rise is 6. And I go over from 4 to 10. So my run is 6, which means it has a slope of 1. M equals 1. And now for my very last one, I've got to go from angle B over to this opposite midpoint. So I'm going from B to this midpoint. And when I count it, I go from 0 to 6. So I've got a rise of 6. And I actually go left from 8 to 5. So it's got a run of negative 3. And that means I have a slope of negative 2. All right, so I've got my 3 medians drawn. And my medians create a centroid. And if you look at this point where they all intersect, it is at 1, 2, 3, 4, 5, 6, positive 4. And so my centroid is at 6, 4. Whew. All right, that was a pretty long notes session. Hopefully this did make sense to you, though, as we did more examples in practice. Keep these notes with you so that you can refer to the table on page 1 over and over and over again, and the more you practice, the more it will make sense to you. Hope this helped, and I will see you in the next video.